Use the given information to find the number of degrees of freedom, the critical values chi-square on the left and chi-square on the right, and the confidence interval estimate of the population standard deviation. It is reasonable to assume that a simple random sample has been selected from a population with a normal distribution. Nicotine and menthol cigarettes, 90% confidence, the sample size n is equal to 27, and the sample standard deviation is given to be 0.26 milligrams. Okay, so the first thing we want to do is, it's asking us to first find the degrees of freedom. So for step number 1, in order to find the degrees of freedom, it's equal to the sample size minus 1. Well, we're given the sample size to be 27. 27 minus 1 is 26. So therefore, the degrees of freedom is 26. Okay, now we need to find the critical values chi-square on the left and chi-square on the right. So in order to find the critical values, we first need to look at the confidence level. Well, the confidence level is given to be 90%. So alpha is going to be 1 minus 0.90 as a decimal, and that gives us 0.10. And then we're going to take alpha divided by 2. So 0.10 divided by 2 gives us 0.05. Okay, so now what that tells us with the chi-square distribution is the following. Chi-square distribution is skewed right, and that tells us that we have the areas on both tails here. So this area represents 0.05, and this area here represents 0.05. So here represents the critical value chi-square on the left, and on this side here is chi-square on the right. Okay? So what we can do is we're going to use StatCrunch to determine what is our critical values. So in order to do that, okay, you want to find the probability of chi-square on the left. Now, if you notice, it's being shaded to the left, so we have our inequality going towards the left. And we know the area is going to equal 0.05. Okay, and likewise, if we want to find the critical value on the right, we can see that it's being shaded to the right. So therefore, we can see that our arrow is going to be greater than or equal to, and again, the area to the right represents 0.05. So let's go ahead and use StatCrunch to determine that. Now it does say that we need to round it to 3 decimal places. So in order for us to find the critical value here, we're going to go to Stat, Calculators, and then chi-square. Okay, so what we're going to do now next is the following. Alright, we need to put in our degrees of freedom. So our degrees of freedom is 26. Okay, and again, to find the critical value on the left, we want to make sure it's pointing to the left, and then we want to put in the area of 0.05. And therefore, rounding that to 3 decimal places gives us 15.379. So therefore, this is equal to 15.379. Now let's just check to make sure our result is correct. So again, we said what, 15.379. And there's our critical value on the left. Okay, now we want to find the critical value on the right. So again, we're going to use StatCrunch here. So using StatCrunch, okay, we want to first erase what's here and then change this to greater than or equal to. And then here we put in 0.05, which is already there. And then rounding that to 3 decimal places, we're going to see that our critical value is going to be 38.885. So that's equal to 38.885. So let's go ahead and put that in there. So we get 38.885. And there is our critical value on the right. Okay, now just in case if we wanted to determine this by using the table, okay, we can do the following. All right. So if we wanted to use the table to find the critical value, okay, in order to find the chi-square on the left, okay, the area that's in the middle here is 0.90, which is the confidence level, and then the area and the tails is 0.05. So on the table, we need to look at the areas to the right. So if we look at the area to the right of the chi-squared left critical value, it's 0.90 plus 0.05. So that means that we're looking for the area that represents 0.95, and then the degrees of freedom is 26. So if we would use the table here, okay, we know that we have 0.95, and then we're going to scroll all the way down to where we see 26, and you can see here that we get 15.379, which is what we got there. Okay, and now if we take a look at the chi-square on the right, okay, the area to the right of that is 0.05, because again, we're given the area to the right of the critical value. So if we take a look at 0.05 and then go all the way down to 26, you can see that we get 38.885. Okay, now that's just to check in how to use the table. Alright, so now step 3, what we want to do is to create our confidence interval. Okay, so for our confidence interval, we need to know the following. We need to know the sample size, which is 27. We need to know the sample standard deviation, and that's given here to be 0.26. We know that our chi-square on the left is 15.379, and we know that our chi-square critical value on the right is 38.885. Okay, and so the reason why we need this information is because we're going to use the formula for the confidence interval. So the formula for the confidence interval is n minus 1 times the sample standard deviation squared over the critical value of chi-square on the right, and then the upper limit is going to be n minus 1 times the sample standard deviation over the chi-square value on the left. So let's go ahead and then put this information into our formula. So we know we have 27 minus 1 times the standard deviation of 0.26, and that's the sample standard deviation, over the chi-square critical value on the right, which is 38.885. Okay, and on the right hand side, we have 27 minus 1 times 0.26 squared all over the chi-square critical value on the left, which is 15.379. Okay, so now what we're going to do is now put this into our calculator. So we're going to evaluate inside and then take the square root of that result. So if we take 27 minus 1, that's going to give us 26. And then we're going to multiply that by 0.26 squared. And then we're going to divide that by 38.885. And then we're going to take the square root of that result. So second square root of the answer. And then they want us to round this to 2 decimal places. So if we round our answer to 2 decimal places, we get 0.21. So that's 0.21 for the lower limit. Okay, so now we're going to do the same thing on the right side. We're going to evaluate inside the radical and then take the square root. So we got 27 minus 1 again, which is 26. Multiply it by the standard deviation of 0.26 squared. And then we're going to divide that by 15.379. And then we're going to take the square root of that. So we're taking the square root of that answer. And then again, we're rounding that to 2 decimal places. So that becomes 0.34. So let's go ahead and check our answer here. So we have 0.21 milligrams for the lower limit and 0.34 milligrams for the upper limit. And there is our result.